Ben Morse here. I'm super excited to be moderating today's session on AI and robotics in heavy civil construction. The panel will feature 3 industry experts, and yeah, just to give a high-level introduction overview of their backgrounds before they join us. Cynthia Brosque. Cynthia blends her Stanford PhD insights and SafeAI experience to lead advancements in construction robotics. In addition to working with SafeAI, Cynthia is an adjunct lecturer at Stanford as well, who connects startups, construction firms that are evaluating robotics and their real-world impact. Also joining us today, we have Scott Wolslager. Scott has spent decades aligning cutting-edge technology within the AEC and manufacturing spaces. In particular, the last 20 years, Scott has spent with IMAGINiT, tailoring technology solutions across civil project categories and various organizations. Also joining us, we have Pat Weber. Pat brings a couple decades of experience in developing automation and robotic systems for agriculture, mining, construction, and the defense sector. And over the last 7 years, Pat has applied his skills and trades at advanced construction robotics. So, so excited to have you all. And once again, my name is Ben Morse. I have operated in the last 10 years connecting startups and construction industry experts. Today, I'm here to facilitate a world-class session on AI and robotics in heavy civil construction. And to be clear, all of the world-class insights will come from the panel. So if you have any issues, go see them about it. But just to kick it off today, I'm actually gonna throw it to you, Patrick, and we're gonna touch on what is the true readiness of AI and robotics in civil construction. Specifically, there's a debate over how widespread adoption, how widespread adoption is in the space and whether the industry is truly ready for full-scale implementation. How do you address that skepticism?
Yeah, thank you. So, I think there's an assumption that robotics and AI, that this is a technology that is always coming, but not quite here yet. But the truth of the matter is that there are technologies that are ready for implementation, in the industry right now. We are actively engaged in commercial operation with our robotic systems, with rebar specialties, subcontractors, and general contractors in the industry today, helping them realize improvements in their labor gap, letting them realize improvements in their productivity. There are technologies that are ready to go out there right now, both in software systems, planning systems, and field robotic systems.
Awesome. And maybe throwing it over to Cynthia, who's dealing with a lot of startups or folks that are trying to engage the industry. Are you seeing some of the same things?
Yeah, definitely. And I think it varies a little bit depending on the specific application, but it's not like we're going to see from one day to the next a full encompassing solution. I think we're seeing advances in like various like sub segments of the industry, and how everything is going to come together. I think there's still a long way to go, but we see a lot of advancement in specific areas.
And Scott, this is where you chime in saying there's no skepticism. Everyone's ready to go.
That's exactly it. I seem to be on a little bit of a delay here, but yeah, I think we've been using, to Pat's point, robotics and robotic automation for a long time in the heavy construction industry. From my days of early civil engineering on large transportation projects, of taking civil engineering grades and sending them to the machines and having them grade out roads and things. But beyond that, though, I think the way that further applications come along and enhance that experience that we've had for quite a long time is, artificial intelligence enabling decision making by a robot, and field engineering that we once had to make decisions about. Now maybe robots can help make some of those decisions and along the path. So this was this looks off. You get to a project and you always have to make grade adjustments, for instance, and can an AI engine make that decision with maybe some quality checking from a field supervisor that the robot is making the right decision.
And when I hear AI really becoming a force multiplier for robotics in construction, is some of that to navigate the balance between simplicity and complexity that exists out there? And maybe I'll throw it to you, Cynthia. Do you think the focus on construction robotics should be to keep things simpler and easier to implement, or have things changed with AI arriving and solving all of our challenges?
Yeah, and I think here we talked a little bit about, I think AI can mean so many different things to different people. Just because you have like an advanced robot or tool, it doesn't necessarily mean that you're using a really advanced artificial intelligence. In some of the cases, for example, when we look at the Roomba as one of the most successful robots in the household and widely used and very easy to learn, it doesn't have a bunch of AI. It's more like, some collision detection and bumping around your house, and that gives it a little bit of the intelligence. And we've seen solutions in construction where are more similar to that versus a more advanced AI. But yeah, I guess kind of my point is for it to be useful, it doesn't have to be necessarily way smarter than humans, or nothing like comparable to humans either. I think we're seeing really useful tools and advances that don't have a really complex AI. Of course, the AI aspect of it is also very beneficial, especially as we are analyzing data that comes from autonomous applications as well. I think that is going to give us a lot of insights into what is currently our baseline of performance.
All great insights. Thanks so much, Cynthia. And I guess, Scott, based upon your experience, working with different partners, what are their realistic expectations for robotics today?
I think most of it is around what is available today is around quality and verification, field verification. It's fairly easy today to take a drone, fly it over a site, compare that to a design model, understand where there's discrepancies, and maybe even just a slab grades and find errors and find problems in a little bit faster way. We've done, and traditionally do that through survey work and field people going out and check. Well, 2 or 3 people walking around a site checking grades, or have a drone fly over the site and capture those grades and then compare that to a model. And somebody can really stay in an office and do that entire workflow, which also improves on the safety concerns, right? You have less people on the site, less injury concerns. So that's, I think, a really practical application today is any type of scanning, whether it be terrestrial, laser scanning, whatever type of scanning, because there's all kinds of types of scanning, to be able to compare that to design models relatively quickly.
Super helpful. Well, we also followed the digital twin presentation, so maybe some ideas, we can connect some ideas there. And
yeah, if you don't have that design model, I mean, doing that type of work is impossible, right? So yeah, this is well led into that digital twin conversation that was prior to us.
Yeah, and really, we're just teeing Pat up here to talk about advanced construction robotics and how practical the application is immediately today. Sort of speaking in earnest here, Pat, what would you say your experience is with realistic expectations from the people that you engage, and where you think you and your team are today?
Yeah, I think that there's oftentimes when bringing technologies into different spaces, sometimes it's a technology first approach where you have a technology and you're looking for problems to solve, and we really take a different bent on that, which is identifying the problems in our industry and how do we solve those with the technologies that are available. Is the issue with labor shortages, is the issue with safety concerns, is the issue with productivity. So we intentionally focused on rebar installation on bridge decks because it was a a labor-intensive critical path process that is essential to our infrastructure development processes. So, we're able to introduce technologies in a way that's amenable to our customers that, lets them improve their existing processes and lets them find new efficiencies in getting their work done. That's a much straighter path to getting technology adopted, rather than saying, I've got this new technology and you really need to use it, but we don't have a clear vision for how it's to be used. If you start from the problem and work backwards, you can realize the adoption much faster.
And sticking with you for a second, Pat, if we're going to talk about starting with the problem, does that make it easier to quantify the benefits of implementing robotics and really driving that cost benefit conversation with your partners?
Absolutely, because then we can speak to our customers, directly in terms that they're familiar with. We can speak to them in terms of, their labor hours savings, or we can speak to them in terms of their project time, productivity, and really speak to them, not as roboticists to a civil contractor, but civil equipment provider to civil contractor. It lowers that barrier, being able to speak to them from their perspective and work within the ecosystem. So we design our equipment to be similar to construction equipment that they work with today. We design things to be useful to iron workers and the laborers who are doing this work today, and we are focused on helping our customers solve the problems that they could self-identify very easily with, needing to solve their labor gap, or improve the safety in what's really a pretty dangerous process.
Yeah, maybe I'll throw it to you, Cynthia. I saw you nodding your head a little bit, but I wonder in the SafeAI context, but also the context of the other companies and teams you work with, how does that cost and benefit conversation go for in your side of things?
Yeah, and I think kind of similarly, once we go into a new site, we also want to make sure that we are keeping to the processes and the regulations of that particular environment. So when we're bringing innovation into a very risk-averse industry, like whether it's mining and construction, some of the things that we need to be on the lookout is, okay, we have the technology piece that enables you, in our case, to remove the human from harm's way, so the operator doesn't have to be inside of the cabin. But that also generates kind of other almost like new opportunities of, okay, someone is going to be on the dispatch center, working kind of at a different role to oversee the operation. And then you start to get a lot of data as well as you're running the autonomous solution, and that data gets compared to the kind of traditional, more human operated. And something that we notice is, I think the more that you run with robots in other parts of construction, or kind of in mining with heavy machinery that is automated, you start to get a lot of really good insights that sometimes they start to highlight some of the shortcomings of data that you have on your traditional way of running the site. And that can translate to predictive maintenance in heavy equipment. That's something that is very interesting to our customers. So try to minimize the downtime of the equipment. How can you leverage all the data that is coming from the autonomous solution to help you run your operation smoother? And in other kind of construction robot applications that I've seen, it also helps understand what's your current rework today. So once you're starting to deploy robots, it starts to show, okay, actually, we don't know what is the performance of the traditional method in some instances. Well,
I guess if we have all that data, Scott, who owns it and what the security of it look like? Maybe I'll yield the floor to you to touch on that.
That's a good question. And it's some topic that comes up quite frequently, especially in Department of Defense work and federal government work, is, where's my data going? Who owns it? Who has access to it? And what types of systems have access to it? In Department of Defense work, especially, you can't just have your plans for a nuclear facility and all the details behind that nuclear facility out there in the public eye, or in some machine learning algorithm that's learning from it. So security is definitely a concern for some type of projects. But kind of back to one thing that Pat said that I was sitting here really kind of hit me is the labor part of this, and the labor part I think is a really important point. I happen to live in Columbus, Ohio, and as some other people in the audience probably know, there's a small $20 billion project going on here with Intel, and that project has really taken our economy and made a mess of it, for lack of better words, on the construction side. And it is, a lot of it is lack of iron workers. We don't have enough. We're bringing them in from Arizona, from Florida, from California into Columbus to do this work. Robotics have the potential to relieve some of that pain of these big projects. And one of my friends actually uses some robotics and is in the rebar industry on this project as well. And, he talks about that and how detailed your plans need to be, your digital twins, your digital models, because robots, they can interpret things, but they interpret things like people do too. And artificial intelligence does as well. They got biases just like we do. And we all go out and read plans today, and then we build something off of those plans. Same thing AI is doing, machine learning, all those things are doing. There's going to be mistakes made. And the security side of that is who's addressing the mistakes, who has access to the mistakes. How does the AI generate RFIs and things like that and need to be made? Is it this the size of the rebar that needs to be on this project, or is it this the size of the rebar? Maybe somebody specs something wrong in the design side, and the AI points it out. Hey, this is an incorrect size rebar. It needs to be number 6 or whatever the case may be. So all those things need to be thought about as the decision-making processes and the workflows that you're asking the machines and AI to do for you, and then who's responsible for quality checking it and along the path, and then also, like I said, who has access to that data, and where that data lives is all going to come up, and especially in Department of Defense and type work like that.
Yeah, and I want to throw to Pat in 1 second on the labor side in particular, but Cynthia, before we leave sort of data security and ownership, would you say there's specific best practices or approaches that you've deployed with your team or seen across your ecosystem of customers?
Yeah, and there's definitely things around the use of AI and where the data is being stored, where something that we've noticed is the idea, despite there's some great applications in the cloud, having like an on-premise type of setting, it's very helpful, especially for critical information. And the other piece, at least for us, is building our own data set. So as you're training, obviously all these biases do come if you are not using like specific design like domain data. So we couldn't just grab like a data set out of Google and start deploying that in mining or construction. We had to first almost like create our own training data set from the actual like construction or mining sites. So that part has been really interesting to see sort of the development, but it obviously also takes more time because you cannot just train from available data.
That makes a lot of sense. And I guess maybe Pat, if you want to touch on the data and security piece for with your lens, and maybe roll that into how that data conversation goes across the labor force that's being impacted or operating differently.
Yeah, I mean, I think that as we bring these technologies into these spaces, there's going to be new sources of data, right? The previous discussion, certainly they talked about, like the BIM data and things like that, but there's going to be huge volumes of data that will have value for contractors and subcontractors, for DOTs, in how they plan for maintenance and how they resolve discrepancies in as-built issues, and even solving who's at fault if there are issues in the as-built world, and the whoever holds the data is going to have the proof as to what's going on, and that is going to bring a tremendous amount of value, and people are going to recognize that there is enormous value there, which in itself that presents the safety concern or the security concern, because as that data becomes more valuable, it will necessarily have greater and greater security impact. And as it relates to the labor force, the technologies, we focus so heavily on the workforce in what we do, because there is a noted shortage of iron workers in this country, and as Scott was saying, frequently for large infrastructure projects, people are being imported from various other states and other areas to come and solve these large infrastructure problems, and that is a huge burden and a logistics nightmare in guaranteeing that you have the workforce you need to get the job done when you need it done. So the technologies bring us the benefit of we can prolong the career of an iron worker who literally can't bend over and continue to tie rebar anymore because his back is shot from doing it for the last 30 years, but he can still operate TieBot. These guys, that they don't want to retire yet, but they can use this to continue what they're doing. And on the other end of the spectrum, the technology is an attractive feature for a younger generation who maybe they're not interested in the heavy manual work of iron work, but if you can train them to work with the new technology and be attracted by operating robotic systems, that's a whole new avenue for bringing people into the workforce. And we're actively engaged on that, working with labor unions and working with career development entities to try to attract and train and build up this modern workforce that we need.
Yeah, it was so exciting earlier for those that caught, I guess Don from Bentley was sharing about the modern workforce and shared a couple of great examples earlier. I wonder, is that actually materializing? And maybe Scott, maybe keeping a pulse on things across a number of partners of yours, is that new workforce arriving? Are they being attracted?
I think so. I feel like an old guy now because I've been in this business for 30 years, but I still feel like a young guy at heart. And I can remember when I first started in this business, CAD was first really introduced. I was one of the first I used the first version of AutoCAD, and then I started using MicroStation and GeoPack and other systems along the way, Civil 3D, Revit. I mean, I've used it all throughout my career, really. And early on in my career, I was in the field construction, mostly bridges and heavy highway construction projects. And while I liked the hands-on and being in the field, I kind of recognized what Pat was saying early on in my career, that I couldn't do that my whole life. It was going to beat me up and it was going to be really hard on me. And I really like the technology side. And I think I tried to do my part in a sense, and technologists have to do their part in explaining that to the younger generation is, there's value in doing the field work. I don't want to discredit that, because there is. We need people like that. But we also need people to be able to bridge the gap between the technology and the actual work that happens in the field. And that's kind of where I've always kind of focused my energy, is trying to bring the field together with design. And it's been a fun career doing that, really, right? Is because it's always a battle between the two, but it is fun trying to get people to work together.
Great points. And I guess I wonder, Cynthia, if you could maybe speak to what is the feasibility of wide scale adoption? Because, as someone who's operating an iPad and TieBot able to operate another iPad and do drywall the next day, and the day after do a painting robot, is that the kind of fungibility that we're looking for from the workforce? Or yeah, maybe speak to just the wide scale adoption across different types of robots.
Yeah, no, that's a good question. I think from my experience, what I've seen is that like the newer generation, first of all, it's still extremely difficult to get people really interested in coming into the workforce. We have all seen the data, especially in developed countries, getting a newer generation to go into trade school. It's still pretty difficult. And I think technology and robotics are kind of bridging a little bit that gap, because people are saying like, okay, what I'm doing in video games that is really fun, I can maybe take some of that and also apply it to my job. So it becomes a bit more engaging. And we're also seeing, you know, VR, augmented reality, all these things are also coming into the construction industry. And I think the newer generation is like pretty excited, and it's easier for them to also pick up these skills because it relates to other things they already do in their day-to-day life, just whether it's using a tablet, etc. But I think that the way we're going to go is focusing on, yeah, we'll see adoption like across the industry as more and more kind of innovation starts to become available. But I think still we will have sort of that hybrid. I think it's not going to be a full-on automation just yet. We know robots still have a lot of limitations, especially when it comes to manipulation tasks. I think advanced construction robotics is a great example of a robot that is doing like fine manipulation, but most of the other cases that we see in the industry are not doing that kind of work. So we know humans are still going to be in the loop for a long time. So I think it's on us also as professionals and innovators in this industry to think about, okay, some innovation is going to happen in the field with these like task-specific robots. Something is going to be more like smarter machinery. Some other aspects is going to be around like surveying and getting better data out of the field. Then we'll have also automation offsite, so kind of prefabrication, all of these type of technologies happening offsite and being delivered to the field. And then we'll have like teleoperation, human-robot collaboration coming into the picture as well. So I think all these like different aspects are going to come up, and we need to find ways of how to integrate everything responsibly, and keeping in mind, I think that the target that we still owe the industry of, you know, 0 incidents in the field. So yeah, I think it's not going to be from one day to the next, but we're going to see like all of these different areas developed and tying it from a management perspective that is becoming really important.
Awesome perspective. Thank you, Cynthia. And I guess I'm wondering, should there be a rebrand from SafeAI to Gaming AI, and you'll get a whole bunch of 20-somethings that want to operate machinery remotely? Anyways,
well, I mean, especially no, but it's a real like concern. I think, especially for mining, heavy civil, like when sites are really remote and people need to fly in and out, you know, every week to go to work, versus if they could work from home and, you know, control a machinery remotely, then that frees a lot of their time and opportunities as well to engage new people into the industry.
It's not much different than our government does, right? Or the United States government does with drones. I mean, they fly them from Colorado and they're all over the world, right? Those drones, they're operating all over the world, not just in Colorado, but they're operating them from Colorado.
I think Cynthia made a really good point about, you know, always having humans in the loop. You know, I think there's this mistaken perception that robotics is, you know, replacing our workforce, and that's simply not accurate. You know, anybody who's out there selling, you know, level 5 full autonomy is blowing a lot of smoke, and there's an absolute necessity for economical robots to be out there working alongside human beings, letting humans do the critical judgment tasks that they're really excellent at, and allowing the robots to handle, you know, these bulk repetitive tasks, and you know, offloading these you know, less interesting problems to the robots, and letting people focus on, you know, solving the change problems and solving the fine manipulation problems that would be extremely expensive with robotics.
And you hit a point there, Pat, that is important too. Is that I've been watching some news about Tesla as a robot lately, and it's a humanoid, right? But as you're speaking there, is that robot still can get hurt, right? There could be some danger in that for that robot in the field, and it could break. So I mean, an injury to a robot is really no different than an injury to a human. Safety still needs to be monitored.
And maybe I'll do a call for any questions. I have one that I want to ask before the crowd, jumps in. And this is one that I don't think we talked about ahead of today, but I'll go around the horn. Curious to know how AI and robotics specifically applied to civil construction can reduce environmental impact when it comes to construction projects. So I'll sort of let someone raise their hand and see who wants to take that first.
I'll take it from a different spin. I think I wasn't really prepared to answer, but when you asked it, the first thing that came to my mind is, I think one of the areas that AI is going to impact the civil industry that we haven't mentioned yet, and is probably not talked about, is in the materials side. I think there's a lot of opportunity out there to develop new materials that we never thought of. And I think I read something not that long ago about Google's DeepMind AI engine generating like 385,000 new material types or something in a day that have never been tested or used before. And if we can get to a point where we can develop materials in a way that we never thought of and never had the math capacity to do and supercomputer probably to do, we're not really far away from that. I think we're, not 10 years away from that. We're years away from that. I think that's a great opportunity, and that has a big impact on the environment side, right? Is, recycling differently, recycling concrete differently, recycling asphalt differently, maybe even not even using asphalt or concrete as we know it today. Maybe some new material that's developed that just transforms the world.
Yeah, and I think maybe also tying into the material consumption side, like being able to reduce rework because you have an autonomous operation regardless of the task, that also allows you to save on materials. We see it in autonomous equipment, because you are controlling it through an algorithm and not driving as people drive. Sometimes you are also able to be more efficient with fuel. So that's one area in which we are seeing in heavy equipment type of benefits.
Yeah, for the types of infrastructure projects that we work on, there's a huge amount of environmental impact in a construction project, especially when you're talking about bridges and you may be crossing environmentally sensitive areas, or you've got to deal with detour routes and traffic adjustments, which bear their own environmental cost. By utilizing technologies like IronBot and TieBot, we've actually been able to allow our customers to reduce their crane usage, which means they don't have to build access roads to locate cranes in different parts of, underneath the bridge, where they, just to be able to service rebar out in midspan on the bridge, for instance. So if you can, reduce that entire problem and not have to build an access road, you can, entire highways and bridge designs have been adjusted because of certain sensitive areas. But if you can reduce that kind of impact, then we can have be able to construct infrastructure in places that weren't accessible before. We can reduce overall construction times, which reduces detour routes and things like that as well. Just increasing the overall efficiency of our transportation and infrastructure systems bears a huge environmental improvement for us as well. Traffic jams alone cause massive environmental problems. Just more free-flowing and more efficient transportation and infrastructure systems are a net environmental benefit.
Fantastic. And I guess just looking at our time here, I don't see any questions popping up, but I did want to at least give the option to each of you to give a shout out to your company, your respective team, and just let folks know where they could learn a little bit more. We are going to share a slide afterwards to any attendees, so we'll leave that to the Building Transformations crew. But yeah, Cynthia, then Scott, then Pat, if there's anything you want to share.
Yeah, and thanks so much for this conversation. It's always really refreshing to kind of see where other people in the industry, what they are thinking on. For us at SafeAI, we are focusing on the retrofit model also. So we go directly to the general contractors or mine or quarry operators. So this is the people that already holds the assets, and we retrofit it with our autonomous kits. So that also allows to extend the life of that particular asset that they already own. And it makes the technology a bit more accessible because you don't have to go after the newest OEM autonomous vehicles. Like, this is the vehicle you already have sitting there that still has 10 more years of lifespan, but how can you bring in autonomy into your existing operations? So yeah, we're very excited about this mission. I think other areas in which we've seen considerable benefits is how automation is also impacting the design. So you can, for example, have a tighter road if you're not actually going to have two people passing each other on a whole road. And I think the same applies to other kinds of robots. So I'm really optimistic about the future of the industry as more and more technologies come into place. So yeah, feel free to check out our website, is safeai.ai. So yeah, we'll look forward to engaging more.
And IMAGINiT Technologies, we are an Autodesk and like a business partner, but we also have 150 consultants that focus on the manufacturing and AEC spaces. And really our primary focus as a business is trying to move the needle on the digital thread, we call it, moving information from design through to construction or design to fabrication, if we're talking manufacturing side, leveraging data in a smart way, digital twins, IoT of things, connecting data, not recreating the wheel at every point on a project is where we primarily spend most of our time. And we have a team of software developers as well that we do have some off-the-shelf products, but we do lots of custom work for customers that are trying to go through this digital transformation process and integrations.
Hi, and yeah, so Advanced Construction Robotics, we actively are fielding our TieBot and IronBot products for rebar installation on bridge decks. So we've been at it for about 7 years now, and we have fleets of robots out there working in the field today. I think we've installed over 3 million ties of rebar ties in the last several years, and IronBot, our newest product, has been seeing very, very nice success in its first deployments, and we've laid nearly 500,000 pounds of rebar with IronBot so far. We're focused heavily on, like I said earlier, working with our customers on improving their efficiencies and helping them solve their problems. We've successfully demonstrated that TieBot and IronBot working together, we can save 50% in labor costs and 50% in schedule savings over traditional manual installation methods using the new technologies.
Awesome. And well, anyways, you heard from the panel. That's all you need. It's been a pleasure to facilitate this conversation, and thank you all for joining today.